Students, in this video we are going to learn about log-based recovery technique. Log-based recovery, it is the process used for ensuring consistency and atomicity of database, particularly when system failure occurs. The system failures may include system crashes, power outages, etc. This log-based recovery technique, it uses a transaction log to store all the activities of a transaction. The activities of transaction includes start of the transaction, write operation of transaction, commit as well as abort of transactions. Whenever a transaction performs any of these operations, the corresponding entry is made into the log. Okay. Particularly, before any changes are made to the database due to its write operation, the corresponding log entry must be written to the log so that whenever system failure occurs, the database can be restored to its consistent state. Okay, so this point is very important point. It has to be noted. That is, before making any update to the database, the corresponding entry must be first made to the transaction log, then only the database can be updated with the latest value. Here, a transaction log which is used to record all the activities of transaction, right? So it is a file, okay, which is usually stored in some safe and stable storage, so that if any failure occurs in the system also, this log file can be recovered from that stable and safe storage. Okay, this is the introduction on log-based recovery. Let's now discuss the type of techniques available in log-based recovery. There are two types of techniques are supported. One is immediate database modification technique, which is also known as undo or redo algorithm. The another technique is a deferred database modification technique, which is also known as no undo redo algorithm. Here, this immediate database modification technique, in this case, changes made by the transactions are applied to database immediately after the execution of each operation. Okay, whereas coming to deferred database modification technique, in this case, changes made by transactions are applied to database only after its successful commit or partial commit of the transaction. Since the changes which need to be made into the databases are deferred until the successful commit or partial commit of the transaction, this is known as deferred database modification technique. Whereas here in this case, since changes are made to the database immediately after the execution of each operation, this is known as immediate database modification technique. Okay, in both the cases, either database update is deferred until the partial commit of the transaction, or else immediately the change is made, as in immediate database modification technique. Irrespective of any of these two techniques, the database update can be made only after the corresponding entry made into the log. First, the corresponding entry must be made into the log, then only the change must be reflected into the database. It is applicable in both the cases. This point is very important. This is what we discussed in the previous slide also. Okay, in both the cases, the log records which are usually used for recording the activities of transaction, right? You can observe here also start record, which is used to record the beginning of the execution of the transaction. This one is known as update log record, which is used to record the write operation of the transaction. In this update record, TI denotes the transaction identifier, whereas XI denotes the data item identifier. V1 indicates the old value, V2 indicates the new value. Okay, this one is known as update record. Whereas here you can observe in deferred database modification technique, in update record there is no old values maintained. This is the significant change between these two techniques. Here in this case also commit record is maintained, here also commit record. It may also include abort record also. Okay, this also may include abort record. Okay, so these are the log records used to record the activities of transactions immediately when they are executed. Okay, in both the techniques these log records are available. Okay, whereas in case of immediate database modification technique, the recovery procedures supported are undo and redo procedures. This undo procedure is applied on uncommitted transactions only, whereas redo is applied on committed transaction only. Here in case of deferred database modification technique, this redo procedure is applied on committed and partially committed transactions. Okay, these two recovery procedures are mainly useful whenever system failure occurs and the system resumes back from its failure. Then in order to ensure the consistency of database, these recovery procedures are helpful to restore the database to its consistent state. We are going to discuss immediate database modification technique with the help of by executing the serial schedule which contains transaction T0 followed by T1. Here T0 it transfers amount 50 from A account to B account, whereas T1 transaction it withdraws amount 100 rupees from C account. Okay, when these transactions are executed, how this immediate database modification technique performs its operation, let us now discuss. Okay, when T0 begin is executed, it means T0 started its execution. The corresponding log is made into the log. Just assume that initially A account to B account, C account initial values are 1000, 2000 and 700 respectively. Okay, and followed by T0 begin, the next operation is read and A equal to A minus 50. So this read operation from database, it never ever disturbs the consistency of database. That's why no record is need to be maintained to indicate the read operation of transaction. Okay, so when write operation is performed, since it is the immediate database modification technique, so after making the corresponding log update record into the log. So what update record indicates? T0 indicates the transaction identifier, A indicates the data item identifier. This indicates the old value, this is the new value. Old value of A is 1000 and after the subtraction of 50 from A account, the new value becomes 950. So since this is immediate database modification technique, the new value of A becomes 950 and this update is made into the log immediately after the execution of making the update record into the log. That's why it is known as immediate database modification technique. And similarly, when write operation is performed on B, the corresponding update record is made into the log and immediately the update is also reflected into the database, since it is immediate database modification technique. Okay, so the next operation is T0 end. So T0 commit must be made into the log. And when T1 begins its execution, T1 start is made into the log, and when it performs the write operation, the corresponding update record is made into the log. Okay, so immediately the update is also, C value is also updated into the database, and the next operation is T1 end. So immediately after that, commit of T1 must be made into the log. So like this, log records are made and the corresponding update is made into the database immediately after the write operation of transaction, and after making the log entry into the log, immediately the update is made into the database. Okay, let us now discuss if in case of system failure, how this immediate database modification technique ensures the consistency of database with 3 different cases. Okay, so in this case 1, if suppose system failure occurs. So here you see write A. When write A is performed, the update record is made, and the corresponding log entries, corresponding database entries also, database update is also made. And when write B is performed, after making the log update log entry into the log, and update is also reflected into the database. So at this point in time, if system failure occurs, when the system resumes back from its failure, it can't see any of the transaction, because transactions were executed while execution those were in RAM. RAM is a volatile memory, so when the system resumes from the failure, none of the content will be available in the RAM. Okay, so the system doesn't have any idea about the previously executed transaction and its state and the consistency of the database also. It do not have any idea. However, database management system, it has to ensure the consistency of database in spite of any scenario. That's what the database management system, particularly recovery manager component of database management system, it looks into the log. Usually, since log is stored into the stable storage, it will the content in log, it persists forever, even if system failure occurs. Okay, so when system recovers from the failure, DBMS, it looks into the log and apply the corresponding recovery procedure. So in immediate database modification technique, there are two recovery procedures are supported. One is redo and undo. As we already discussed, redo is applied on committed transaction which contains both start as well as commit record, and this uncommitted transaction, it contains only start record. Okay, so now in our case, this T0 is an uncommitted transaction because it contains only the start record. There is no commit record at all. That's why we have to apply, the DBMS, it applies undo procedure on T0. When undo is applied, when undo procedure is applied on T0, the new values of A and B which were updated by T0, these new values are undone and the old values of A and B are restored. Okay, so what are the new values? 950 and 2050, right? Those values are undone and the old values of A and B are restored into the database. Okay, because this transaction is not committed. That's why, to ensure the consistency of database after when the system recovers from the failure, this undo operation is applied and the consistency of database is also ensured. Okay, as well, no partial update of transaction is reflected into the database. In this way, this immediate database modification technique ensures the consistency as well as atomicity of database. Let's take one more case where system failure occurs after the successful execution of T0. Okay, so when T0 end instruction is executed, T0 commit is made. So at this point in time, if system failure occurs, when it resumes from the failure, what recovery procedure DBMS will apply? Since T0 is the committed transaction, on committed transaction a redo procedure will be applied. So redo will be applied on T0. So when redo is applied on T0, the new values of A and B, though it is already available in database, it has to be reapplied once again to the database. Okay, so when they are reapplied, then A and B once again rewritten to database. Okay, let us take one more scenario where system failure occurs at the end of the successful execution of T1. Here you see, when T1 end is executed, the corresponding entry is also made into the log, So at this point in time, if system failure occurs, then when it resumes from the failure, it looks into the log. Both the transactions are having start and commit record. So both are committed transaction. On committed transaction, redo procedure is applied. So accordingly, when redo is applied on T0 and T1, new values are again updated into the database. When redo procedure is applied, it need to be applied in forward direction. That is, redo must be applied on T0 first and then T1 first. Okay. So when redo is applied on T0, once again AB values are updated. When redo is applied on T1, C values again updated into the database. Okay. So you can see when redo is again executed, A, B, C values are again rewritten. Okay, this is about immediate database modification technique. Students, if you find this video useful to you, kindly subscribe this channel. Thanks for watching.